So next piece I want to look at is making sure we know how to handle irrational and complex solutions. So making equations that contain those things. And the key thing to remember is these types of answers are always going to come in conjugate pairs. So here's some examples. Positive square root of 3 and negative square root of 3. Those would be an example of an irrational set of solutions there. Plus or minus 2i would be an example of an imaginary scenario. And then here we have another example of an irrational, and then here we have one of a complex solution. So they're always going to come in pairs, a positive and a negative one. Now note, the only difference is the sign in between. So again, just for showmanship here, this is two answers, 4 plus the square root of 2 and 4 minus the square root of 2. That's what this is representing. Just like this would be representing 3 plus 4i and 3 minus 4i. Okay, so the only difference between the two answers is the sign that's in between. So if we look at this first example, there's our solutions. We've got intercepts at -2, at 3, and then we've got these two irrational ones at the end. So we're going to go ahead and make our factors just like we would before. And just as before, we're going to make them opposite. Now the key here is we want to go ahead and multiply the conjugate pairs together. Alright, so we talked about on the first video that we could multiply in any order, and we could do that. It would just make it a lot more difficult to do that here. So to keep it easier on ourselves, we should multiply those two things together. And I'm going to go ahead and multiply those two things together. So when I do this one here, I've got my x squared, and then I've got a minus 3x and a plus 2x. So a minus 1x is my middle term, and then minus 6. So when you FOIL that out, there's your result, x squared minus 1x minus 6. On this one, since I have a conjugate pair, I don't actually have to do the FOIL process. Remember, on a conjugate pair, the O and the I will always cancel themselves out. So really, all I have to do on this one is x times x. And then at the end, I have the square root of 5 times the square root of 5. Now that gives me the square root of 25, which is equal to 5. So when I FOIL this out, there's my result, x squared minus 5. And now I can take these two things and I can multiply them together. And what I'm actually going to do is I'm going to take this binomial and I'm going to distribute it to the trinomial. I'm going to go right to left instead of left to right. So I'm going to take the x squared and multiply it to all three of those parts first. So you're going to get an x to the 4th. And then x squared times negative x would be a minus x cubed. And then a minus 6x squared. So when I distribute the x squared from this binomial, there's my result. And now I'm going to distribute this negative 5. So negative 5 times x squared. Negative 5 times a negative x. And then plus 30. And there's the result from that one. So now I'm going to do my like terms. And we would be finished with this one. So what would our classification be on this one? Well, if I wanted to classify the answer too, now my lead power is 4, so it's a quartic. And there's 1, 2, 3, 4, 5 terms, so there's no special name for that, so we would just say polynomial of 5. And there is our solution here. And if I wanted to check my answers, remember, this is where now I could take any solution I wanted and I could sub it in for the x value here. And if I've done it correctly, it should equal 0. Here is a second example. So we've got zeros at -1, we've got a double root at 0, and we've got a 0 at 3i. So let's go ahead and start making our factors. So there's the factor for -1 solution. Now double root at 0, that's just like an x and then another one. So I'm going to put the x squared, and I like to put that out in front. And then we have this 3i, so x minus 3i would be our factor. Now, what I want you to note on 2 versus on 1, notice on 1 we had 2 irrational roots. They were conjugate pairs to each other. This one we're only given 1. Now, we know they always come in pairs. So what we have to do on this one is we have to remember that negative 3i is also a known solution, even though it's not in the given information, because they always will come in a pair. So now we add that factor, and there is our factor set up for those known zeros. So even though we were only given those zeros, we knew there was an extra one because they always come in a conjugate pair. And now same thing. I'm going to put these two together. So x cubed plus x squared. And then I'm going to put those two together. So again, I don't have to FOIL this out. I just got to do the first and the last because they're conjugate pairs and the O and the I will cancel. So x squared. And now I'm going to have a minus 9i squared. I'm going to put that over here real quick. So when I do negative 3i times positive 3i, I get a minus 9i squared. Now, I squared, we said, is equal to negative 1. So if I substitute that in, I end up with a plus 9 for that spot. So x squared plus 9 is what that foiling out would give us. And now I take these two answers and I go ahead and multiply those together. So now I'm going to FOIL. So x squared times x cubed would be x to the 5th. And then plus 9x cubed plus x to the 4th plus 9x squared. So the only thing left to do here is to remember for standard form it's got to be in order from highest to lowest. So I need to switch the order to put this thing in legit standard form. And there is our polynomial. So this one would be quintic, because it's a 5th power. And then that would be a polynomial of 4. I'll shorten that up to just poly. And same thing, I could check my answers. And now just to show you, we could use any one. I'm going to use the 3i. So if we plugged 3i into our equation, oops, let me make that a 3i, not an x. Does this stuff work? So 3i to the 5th power, well, that's 3 to the 5th and I to the 5th. 3 to the 5th is 243. And then 3i to the 4th power, well, that's 3 to the 4th, which is 81, and then I to the 4th. And then 3 cubed is 27 times 9 is 243, and then this is I cubed. And then this is 9 times 9 would be 81 I squared. So now this is where our knowledge of our i's come into play. So I to the 5th, remember, if we divide by 4, we would get 1.25. That 0.25 means there's a remainder of 1, so it's equal to I to the 1st. So this is actually equivalent to just 243i. I to the 4th is equal to 81. Or excuse me, to 1, excuse me. So 81 times positive 1 gives me 81. I cubed is equal to negative I. So this actually becomes a minus 243i. And then I squared is negative 1. So this becomes a minus 81. And if we take a look, these two things cross out, those two things cross out, and we would be left with 0. So even with the i's checking, it still works out. So our equation's legit. And moving on to this example. So now I've got an irrational root and I've got an imaginary root. And same thing. Now note, I don't have the buddy, so I have to account for, well, plus square root of 2 also has to be a solution. And same thing here. If I is an answer, then negative I has to also be a solution, because they always are going to come in those conjugate pair pieces. So there's actually 4 zeros that we know, even though we were just given the 2. And we're going to make our factors. And same thing. We're going to go ahead and multiply these two things together. So if, again, I don't have to do the whole FOIL process. It's just going to be x times x, so x squared. And then minus the square root of 4. So again, the square root of 4 is equal to 2. So when I multiply that out, I just get x squared minus 2. And then over here, again, first and last is all I have to do. Now here I get minus I squared. When I do the I times the I have a negative I times a positive I. This is negative 1, so minus a negative 1 turns this into a plus 1. And there's my solution. And now I can multiply this out. So x to the 4th plus x squared minus 2x squared minus 2. And here I can combine the like terms, so x to the 4th minus x squared minus 2 would be my answer. If I needed to classify this, well, the 4th power, the vocab word is quartic. And then there's 3 terms, so the vocab word for that would be a trinomial. And again, I could check my either answer. I could plug in I, and this stuff would work out. I could plug in the square root of 2, and this thing would work out, if I've done it correctly.